The story of human survival and development is an age-old tale between man and that most essential element of life, water. Within this human history are amazing twists and turns, as well as great wisdom, which still manage to impress us to this day. Since ancient times, hydraulic engineering has been continually improved upon in order to safeguard the livelihood of people and enable the economy and industry to move forward. The development of the Sherman Reservoir is a story written together by man and nature. Let us journey into its wonderful world. Taiwan has high mountains and fast-moving rivers. Because of this geological impediment, although Taiwan has plenty of rain, it used to suffer from severe water shortages. Therefore, hydraulic engineering is now a very important part of Taiwan's basic infrastructure. Early on, the Taoyuan area was known as home of 1,000 ponds, thanks to the countless man-made ponds dug by the locals. Although these ponds solved some issues related to water shortages, the ponds would dry up if the dry season lasted longer than usual. This irregular supply of water adversely affected crops and livelihoods. Therefore, the Sherman Reservoir, finished in 1964, became northern Taiwan's lifeline for everyday water needs, industrial protection, and natural ecosystems. Dahan River, originally named Da Ke Kan River, is an important irrigation source for Taoyuan. When it passes the Sherman area, the river is perfect for damming because of the special geography of the opposing Shizhou and Sherman Mountains. The Sherman Reservoir Construction Committee was formed in 1956. The reservoir was completed after 8 years of design and construction, with over 7,000 contributors. With such a vast area under construction and treacherous terrain, the project was a huge and arduous undertaking. Because of this, the construction of the Sherman Reservoir also created architectural experts who were involved in other major projects. This is part of the Sherman Reservoir's far-reaching impact. Facilities at the completed reservoir can be divided into two categories: the dam and supporting structures, and the irrigation and water supply structures. Main structures include the reservoir, dam, spillway, power generation plant, permanent drainage floodgates, the back pond and the back pond weir, Sherman Canal intake, Taoyuan Canal intake, emergency flood relief tunnel, etc. The total surface area of the reservoir when full is 8 square kilometers, with a volume of 309 million cubic meters. The dam was originally designed as an arch dam, but was changed to an earth and rock-filled embankment dam because of safety and economic concerns. The dam itself is 133 meters high, with a total volume of 7.06 million cubic meters. The Sherman Reservoir's catchment area spans Taoyuan County's Longtan, Daxi, and Fuxing townships, Hsinchu County's Guanxi, Jianshi, and Wufeng townships, and Datong Township of Yilan County. The reservoir is located at the midstream of the Dahan River system. Sherman is Taiwan's first multi-purpose water resource development project and has improved agricultural production, industrial development, and overall living standards, and lessened the threat of floods in northern Taiwan. Along the way, the Sherman Reservoir also faced many daunting challenges, like strong winds, storms, flooding, landslides, and sedimentation. All of these things affect the operation of the reservoir and may shorten its operational lifespan. This is where the wisdom of the hard-working employees of the reservoir comes into play. Next, we will take a look at the reservoir's functions and the progress of the renovation project. Hydraulic engineering has a major impact on people and the economy The Sherman Reservoir has 5 main functions: water supply, flood control, power generation, irrigation, and tourism. The water it brings brought a boom in northern Taiwan's development. The reservoir mainly supplies water to the Taoyuan area, Banxin in New Taipei City, and Hukou in Hsinchu. The Sherman Reservoir's earliest objective was to provide water for irrigation, and the Taoyuan and Sherman Canal intakes were built to provide citizens with adequate amounts of water in a timely manner. The reservoir also works actively to implement alternative irrigation, strengthen irrigation management, and conserve the amount of water used. The Sherman Reservoir once reached a peak of irrigating 52,000 hectares of farmland in 1969. Since then, this number has declined because of rapid commercial and industrial development to 36,753 hectares. The irrigation provided by the Sherman Reservoir is a boon to farmers, but the role of the reservoir has changed over time. In its early days, 95% of the water was farming-related, while public water supply was only 5%. Because of economic development, industrial restructuring, and population growth, water use has changed. In 2010, for example, agricultural use of water was 53.09%, public consumption was 45.67%, and industrial use only accounted for 1.24%. In the rise and fall of these figures, we can see the change in Taiwan's industries. The construction of the Sherman Reservoir has contributed to economic development, urban development, and the growth in population numbers downstream. The Sherman Reservoir supplies northern Taiwan with approximately 1.4 million tons of water every day, as well as the industries of Taoyuan's 8 big industrial areas. Not only does the Sherman Reservoir provide the public with a steady supply of water, it provided stability that made population and economic growth possible. Hydropower is an important natural resource and is the purest form of green energy. The Sherman Reservoir has 2 power-generating plants, the Sherman Plant and the Yixing Plant. The Sherman Plant has been in operation since 1964. The Yixing Plant is one of the major facilities built after the completion of the reservoir itself and has been in operation since 1983. It was Taiwan's first remote control power plant, with both power generation and shutdown control with remote control by staff in the Sherman Plant 30 kilometers away. The 2 hydropower plants generate an average of 420 million kilowatt-hours of electricity and were instrumental in Taiwan's early development. In the aftermath of the 9/21 earthquake, the plants were vital in restarting Taiwan's power grid. The power plants fully utilize the river's hydropower. Combined with Taiwan Power Company's electricity development plan, they meet the needs of the people and help to move industrial development. The Sherman Reservoir's flood control capabilities are mainly used to regulate Dahan River's upstream floodwaters and reduce the possibility of flooding in the greater Taipei area. The main facilities are the spillway and the drainage tunnel. The Sherman Reservoir spillway gate is a 6-gated overflow gate with a maximum discharge rate of 11,400 cubic meters per second. The drainage tunnel, an addition completed in 1984, was commissioned after review of the dam's hydrology. The tunnel is located on the right bank of the dam and has 4 floodgates. The drainage tunnel is capable of discharging 2,400 cubic meters of water per second. In addition to the aforementioned functions, the Sherman Reservoir is also a wonderful tourist attraction for visitors. In addition to such places like the Yishange Museum, Huancui House, Shizhou Park, the Maple Forest, Dieyuan, etc. Visitors can also learn about nature in this natural classroom and learn to love and appreciate water. The Sherman Reservoir boasts abundant natural and cultural resources. Its value is worth exploring again and again. In order to obtain a complete set of meteorological and hydrological data, the Sherman Reservoir has 5 water flow and height gauging stations, 16 rain gauge stations, and 6 weather stations to form a complete hydrological network. The data is collected simultaneously by wireless remote control. Meteorological data collected in the catchment area include rainfall, rate of evaporation, temperature, relative humidity, barometric pressure, and wind speed and direction. The most important data is rainfall, which can be used to project how much water will flow into the reservoir and serves as a basis for allocating water and implementing flood control measures in the case of typhoons. Hydrological data include the water level, flow rate, and turbidity. Monitoring turbidity is an important indicator for maintaining the reservoir's sediment content level and for the catchment area's conservation efforts. Nature presents daily challenges to the operation of a reservoir. The Sherman Reservoir's catchment area is surrounded by steep mountains with fast-flowing rivers. The ground is weak and the soil is soft, so whenever a natural disaster such as a typhoon or earthquake occurs, landslides wash rock and earth into the upstream catchments. This results in increased sedimentation in the reservoir, which shortens the reservoir's service life. In 1963, just as the Sherman Reservoir was nearing completion, Typhoon Gloria brought record-breaking floods and sediment deposits. In order to extend the reservoir's service life, a series of renovation and construction projects was launched, which included building sediment dams to block landslides upstream. Every hurricane is like a test. During a storm, the weather can change in an instant. Staff at the reservoir must keep track of the latest information in order to protect the reservoir and the public. The Sherman Reservoir also has water release alarms and overflow alarms to alert and protect citizens downstream during flood control operations. But storms themselves are not the only problems. After a large storm or typhoon, water quality in the reservoir declines. For example, in 2004, Typhoon Iri brought unprecedented amounts of rain to Taiwan. The rain caused a wide collapse of the catchment area. The water purification plant was not able to handle the high turbidity of the water, and Taoyuan was cut off from water for 17 days. In order to supply water to the public, staff set up an emergency pump and water intake line in front of the Sherman Reservoir Songtai viewing platform to skim relatively cleaner water off the top levels. In consideration of the amount of pressure put on the crest of the dam, the crest level pumping phase was shut down after the 960,000 tons of water target was secured. The remediation of the Sherman Reservoir and its catchment area included implementing the vertical profiling system. New intakes at 220 meters, 228 meters, and 236 meters respectively will allow for extraction of cleaner surface layer water during storms. These intakes replace the 195-meter high-turbidity Sherman Canal bottom layer intake. Different intakes allow for flexible planning to prevent a cutoff of water and protect the public's right to clean water. The concepts of sustainability and conservation are present not only in the reservoir and dam areas, but also in the catchment area. Good soil conservation helps maintain good forest cover and prevents soil loss from erosion and landslides. The staff actively educates the public on preserving the soil in the catchment area to maintain water quality and natural habitat. The reservoir's staff is working day and night to extend the operational life of the reservoir with mud pumping boats and dredging projects. The staff is insistent on extending the usefulness of the reservoir. With their concerted efforts, Sherman will continue to provide clean water and vitality to the area. The Sherman Reservoir is rich in natural and cultural resources, both of which are interwoven into a captivating tapestry of life. The environment and water quality of the catchment area's streams and lakes affect the habitat of many different creatures. This vast area of 14 tributaries nurtures many aquatic creatures, riparian plants, and hydrophilic animals. Terrestrial organisms include a diverse range of animals, including mammals and birds, as well as various plants. The area features more than 30 types of rare animals, which are classified as protected species. Aquatic organisms include plankton, shrimp, crab, snails, aquatic insects, and various fish species. The Sherman Reservoir